Following on the previous part where we drew the handles in our tool, you can find a link to the first part in the description. Now we're going to add interaction. So for that, let's head back to our plugin script. I'm going to expand again. And first, at the top of the script, we're going to need a new global variable to store a reference to the anchor that we are currently dragging. So let's create a new dragged anchor variable. And this one is going to be a dictionary, because remember from the previous video, our anchors are small dictionaries that we build in our drawing function. Now the first function we're going to add here is going to be a helper to drag one of the anchors. So we're going to do some transforms, some calculations to move it based on how you move the mouse cursor on the canvas. So something like that. When the user clicks and drag on an anchor, it's going to follow the mouse cursor. In order to do that, so let's add a new drag to function. We're going to take a variable called event position because we'll use the input event position, which is in game space. This function will not return anything. So first, if we don't have a drag anchor, we're going to return from that function. And then we can start the calculations. We want to use the transform matrices again to transform our events position to a position that we can work with relative to the anchor. So we're going to calculate first the invert viewport transform. So this one, again, I looked up the documentation to figure out how to transform the positions on the canvas. It's not something I know by heart, but you do it this way. So you want to take the invert viewport transform. So inverted, it's going to be equal to our rect extents viewport global canvas transform. So we call get viewport dot get global canvas transform, which is going to return the global canvas transform for the viewport this node is in. Now we can use that to calculate the position of the input event, so of the mouse cursor inside of the viewport. So let's call this viewport position. Again, it's going to be vect2, and we're going to use our viewport transform inverted, and we're going to use the xform function to calculate the position on the canvas. So by position and the canvas, I mean a position in this space here, in this square, and based on the, again, zoom level that we have as well. This is the kind of coordinates that we need to get our drag effect. So now we need to do another transformation. So let's get another transform matrix that we're going to reverse as well. Let's call it, it's the global transform inverted of our rect extents. So we're going to use rect extents here, get global transform directly, and we're going to call a fin inverse as well to invert the transform matrix. From there, we can calculate the position of the mouse relative to the node center. So let's call the new variable target position. It's going to be a vector2 again, and we're going to use our global transform inverted, call xform again to take our viewport position. And so we can call vector2.round to make sure that we have integer positions, that we have pixel perfect positions on our rectangle. Now we can calculate finally the target size for our node. So it's again going to be a vector2, and we're going to take the target position minus the rect extent offset. And so we're going to take the absolute value of this vector. So this gives us a vector2 because we subtract two vector2s, and we can use vector2 dot absolute here to get positive values on both axes because we want to get a size, and multiply that by 2 because as we get the target position relative to the rectangle center, this gives us half the size of our rect extent. And finally, we assign it to rect extents.size. We're going to set it to target size. And there you go. We have our drag function. Now we have the hardest part of the plugin done. We're going to add input support. So for that, we need to overwrite a virtual function called forward canvas GUI input. Godot is going to feed input events to this one. And there again, we can return from the function if the input that we get is not interesting or not relevant to our plugin. So if there's no rect_extends, or if rect_extends is not visible, so if not rect_extends.visible, we return from the function. We don't want to drag the anchors around. And this function needs a Boolean value to tell Godot if you consume the input event or not. So return false to say that you don't consume this event in that case, so that Godot can feed it to other nodes. And also let's add a return false at the end of the function just to make sure that we return a value on every path. So now the first two events that we want to handle is clicking on one anchor and releasing the click. So for that, we're going to check that the event is an input event mouse button. And we can check the button index in that case. So button index is equal to button left, the left mouse button. In this case, we are clicking with the left mouse button. So we can make a first check to initialize the dragging. If we don't have a dragged anchor, this is where we're going to store the anchor the user clicked on, and the event is pressed. It means that we are clicking on one of the anchors, or we are clicking somewhere at least. And then we want to check if we are clicking on an anchor. So for each anchor in our anchors array, we're going to check if the mouse cursor is inside the anchor's rectangle. So if the mouse cursor rather is not in the anchor's rectangle, so remember our anchors are dictionaries and they have the anchor's position, but also the anchor's rectangle, which is a rectangle 2, on which we can call the hasPoint method. And we can check that it has the event's position, so the mouse cursor's position in it. If it's not the case, we continue to the next anchor. So we check all four of them. Now, if we do have the mouse cursor on top of an anchor, we're going to assign it to the dragged anchor, and we're going to return true. We're going to return from the function. At this point, I should say that we're going to do two passes on the input method. First, we add the input checks, starting, stopping the drag, and detecting the drag. And then we'll need to use the undo and redo object from the Godot editor to actually drag, to actually affect the node. Okay, so next condition, if we lift the mouse cursor. So else, if we have a dragged anchor for one, and the mouse event is not pressed, then we're going to reset dragged anchor to an empty dictionary for one. We also want to call our drag_to method. That's going to drag the anchor to the event's position. And we're also going to consume the input event, so we return true. And now we get to the dragging part. So in the first block, we only process the mouse button event and make sure that we are dealing with the left mouse button being clicked or released. Now for dragging, we can do a few things. First, if there's no dragged anchor, we can return false. We are not interested in the input. Basically, we only want to keep processing the input if the user pressed the left mouse button. At this point, we can listen to mouse motion events if we have a dragged anchor, if we have an anchor to drag in the first place. So if we have an input mouse motion event, so if event is input event mouse motion, then we can call our drag_to method here. So we drag to the event's position, just like we do right here above. And we are also going to update the overlays. So we are going to update the drawing on the canvas, and we consume the input event. But dragging is that simple. That's all we do. We do a final drag when we release the left mouse button, and then we will commit the action. So we'll do that in the second pass on the input method. Now there's one last thing we can do, it's canceling. That is why we are making that check here. We can check that the escape key is pressed or that the UI cancel key is pressed like so. So if the action UI cancel is pressed, we are going to cancel the event. So dragged anchor, we reset that to nothing so that we can click again and restart the loop, and we consume the event. So that's it for detecting the input. Right now, we're only detecting the input. Now, this won't do anything at this point. You could print to the console and see that the function gets run and that you do get a dragged anchor and it gets reset and all that stuff. Our drag-to function will not do anything in the editor right now, though, because for that, you have to use the actions history in Godot. So you have to add events to tell the editor, I want to store that change in position that comes from this drag-to method. To handle the undo and redo and committing actions in the editor, we have to use an undo redo object in Godot. So let's check the documentation, go to undo redo. It's a class here, and you have a few methods here to add do property and add undo properties. So you're going to pass an object to Godot, our rect extent, and say this property, for example, its position or its size, I want to update it, right? And you give the starting value and the target value if you want. And so this is going to add the action to the history. And once you are done with the interaction, so in our case, when the user is going to drag the handle to a certain point, and when they release the mouse button, we're going to commit the action. So the history will only store the original position and the position of the anchor when the user released the key. And then you can call redo undo to undo one step in the editor. That's the same thing as doing Control Z. That's the function that Godot calls when you do that. So let's go back to where we detect the first mouse click, line 73 in my case. So once we have our right anchor here, once we found the anchor that we want to work with, we're going to first get our undo redo object. We're going to store it in a variable, and it's going to come from get undo redo, which is another method that we get from editor plugin. This gives us that undo redo object from the editor, and then we can call methods on it. So we're first going to create an action, and an action is just going to be what you see in the console when you do a certain action. So say I have a 2D object and I move it. You see move canvas item. This is the name of the action when you move something on the canvas, when you move a 2D node. So I'm going to reopen the rect extent scene. There you go. So we can name it whatever we want. Let's say move anchor or move rectangle anchor, rect extents, let's say. And then we're going to add undo properties. So we're going to tell Godot, I want you to store an entry in the history for that action that we just created so that we can undo it later. So undo.add undo property. So we have to pass in the object. That's going to be the rect extents that we modify. The property's name, it's going to be size for the first one. And the starting point is rect extent.size. Duplicate the line, and we're going to do the same for the offset. Even though we're not going to modify it directly from the plugin, you could only use size. Let's just work with the size for now. And that is it. So now we're going to do the opposite event, the opposite thing, when we release the mouse button. So in the second part of that block, so we get the undo redo object again. So we want to call get undo redo. And then in our undo object, we're going to add a do property this time. So we're going to apply the change to Godot. We're going to tell at this point, I want to store the difference between my starting size and my final size. So we're going to pass in rect extents. We're going to commit the size, and we're going to pass the rect extents current size. So this is at the end of the dragging process that we do that. And we call undo.commit action at this point because the user is releasing the left mouse button. So we want to really commit the change to the editor's undo stack here. While we are dragging the anchor, we don't want to do anything to the do or undo. We don't want to update these constantly. We'll only store the starting point and the end point here. There's one last part where we need to use our do undo. It's when we cancel the operation. So there again, we want to get our undo object. Note that you could store it earlier in the function so you don't have to declare it 3 times. But I like to make it clear that we don't always use that undo object. So I use the variable in the lowest, the highest, should I say, indent level as a local variable where it's being used. So there, what we can do is directly commit the action. So we added the ability to undo it when we left click. We didn't add the ability to redo the action because we don't release the key. But we're going to undo it straight with the undo method on that. This is how you cancel an operation, right? You've moved the rect extend to some place and you've stored its starting point when you left click. So now when you press the cancel key, you want to say, okay, I commit that element to the history, the original size, and I undo the state of the object back to its original size. And with that, your plugin should be pretty complete. So let me go back to the editor and select rect extend, and you should be able to click, drag on the anchor and see the rectangle resize. If I press escape, you will see it resize to its original position. If I click and release, you will see a print in the output console saying move rect extends anchor. So the action has been committed to the undo history. And that is the full plugin, the first version of the plugin. It's a fairly simple one, but this shows you how to create an interactive tool that you can work on the canvas. The same principles will apply to many tools you can create. You could do more than we have here because your overlay is a control node. So as I said before, although I have not tried it yet, you should be able to add new nodes under that, probably add some floating bit of interface. Again, that's something to check, but I've seen Andreas Ezo do it in Godot 2 already, so that should definitely be possible. That said, thank you very much for watching. Be sure to check OpenRPG because we're doing a lot of work on that and you can get all the source code for free. If you have more questions, leave them in the description box below. And that said, be creative, have fun, and see you in the next tutorial. Bye-bye.